Hi guys. Okay, a particular solid has surface area S and volume V. If a similar solid has surface area 2S and volume V plus 10, then V is equal to this, where A, B, C, and D are positive integers and C has no perfect square factors greater than 1. Okay, so given the solid, we know solid 1 has, let's say, length L, surface area S, and volume. Surface 2 has let's call the scaling factor times L, S, 2S, and V plus 10. And we're trying to find V. So, is there any way that we can get from length to surface area? Well, let's pretend that this solid is a cube, for example. Cube, let's say length 1. 1, that would mean its surface area is, like edge length 1. That would mean its surface area is 6, and its volume is 1. Then let's say we change this to 2. So now it's 6 times 4, which is 24, and then our volume is 4. So we increased if we times 2 this, we times 4 this, and we times 4 this. Let's try this again. 1, 6, 1. And then we go to 3. Then we go... no, this is 8. I did this wrong. It's 3, and then we have 2 times 2, so this is 9 times, so 54, and this is going to be 27. So we multiply this by 3, we multiply this by 9, we multiply this by 27. So here we can see a cube shares this relationship where if we x this, we x square this, we x cube this. Maybe let's look at it's another easy shape. Let's look at a sphere. A sphere has radius 1, has surface area. Oh, surface area of a sphere is. Shoot, what's the surface area of a sphere? Sphere surface area is 4/3 pi r squared, I think. Or is that a cone? Shoot. 4/3 pi r squared, I think. So this would just be 4/3 pi. And then this would be pi r cubed, so this is just pi. I'm gonna check this actually. A sphere surface area. Okay, yeah, I see. I did this a bit wrong. This is 4 pi r. The surface area is 4 pi r squared. So this is just 4 pi, and then this is 4 pi r cubed. So, or 4/3 pi r cubed. And if we change this to 2, surface area goes to surface area is 4 pi r squared. So this changes from 4 pi to 16 pi. And then this is 4/3 pi cubed. So this becomes 32/3 pi. So this again changes by 8 when this changes by 2 when this changes by 4. Okay, so I think it's generalized that if this changes by surface by scaling factor, this is times scaling factor squared, and then this is times scaling factor cubed. Okay, so scaling factor we know is equal to square root of 2. Because using this we know S1 is equal to S1 times scaling factor squared is equal to 2S2, so then, or is equal to 2S1. So scaling factor is equal to root 2. So then we know root 2 cubed times v is equal to v plus 10. So this is going to be 2 root 2 v minus v is equal to 10. So 2 root 2 minus 1 times v is equal to 10. V is equal to 10 over 2 root 2 minus 1. Just doing, what do I need to do? I need to do is equal to 10 over negative 1 plus 2 root 2, then we get the conjugate. So 10 times negative 1 minus 2 root 2 over negative 1 plus 2 root 2 times negative 1 minus 2 root 2. So this is just going to be negative 10 minus 20 root 2 over 1, and then it's just going to be minus this squared, which is going to be 4 times 2 is 8. So negative 10 minus 20 root 2 over negative 7. So getting rid of the negative, we have 10 plus 20 root 2 over 7. Wow. So just add these all together. 10 plus 20 plus 2 plus 7 is 39. Let me check. Holy cow, I actually got that right. Holy cow. And I even did it as simpler than they did. They used the quadratic formula, I used something else. So, wow, amazing. I did get some small help from finding the surface area of a sphere and volume, but like I would have known that if I was actually training for this, because I'd have to memorize that. But like, holy cow, I got that right. I thought that I was not going to get this. This one seemed way too hard for me, but it was actually kind of simple. Cool. Thank you guys for watching. I'll see you guys tomorrow. Bye.